Welcome to the next lesson on waves. So this is Waves Lesson 6, the wave equation, and I'm Mr. Pratt, Science Director with Outward Grange Academies Trust. For this lesson, you're going to need a pen, calculator, paper or an exercise book, or if you've got access to a printer, you could print the Google Doc, and make sure that your mobile phone is out of the way unless you're viewing this video on it. Okay, straight into the starter. I want you to match the correct letters up with the words. This should be knowledge that you've got from previous lessons on waves. I'm just going to give you about 30 seconds to a minute. Be quick if you've not quite done. Right, just quickly self-mark it then. So frequency is the number of waves passing a point each second, letter C. Amplitude, maximum displacement of a point on a wave away from its undisturbed position, letter E. Period, time for a particle to make one complete vibrational cycle. Trough, bottom point of a wave. And wavelength, distance from a point on one wave to the equivalent point on the adjacent wave. So that was letter D. Just give yourself a quick score out of 5. Okay, outcomes then. Probably the most important thing in this lesson is to be able to recall the wave equation. It comes up quite a lot. It's got a required practical with it, so you're even more likely to be asked it. Also, aspire outcome. Use the equation, substitute some numbers in, but also rearrange it. Okay, so let's just look at the context of the wave equation. So let's have a look at what it really means. So these waves here underneath the duck, they're travelling across the surfaces of a pond, and the length of each wave, so the wavelength, is 0.25 metres. That's 25 centimetres. So if we then know that 2 waves pass under the duck each second, we'd say that the frequency is 2 Hertz. 2 Hertz, 2 waves every second. So what I'd like you to do then now is, can you work out the wave speed, not using the equation, just using that information that you've got there? So can you find the wave speed in meters per second? And if you're super confident, could you actually use that to come up with the equation? I'm going to give you 2 minutes. "30 seconds then. Alright, so let's see how you got on. So it tells us there that the frequency is 2 Hertz. So you get 2 waves in 1 second. So you get 1 wave in half a second. So that would mean 0.25 meters in half a second, which would be 0.5 meters, half a meter every second. So the wave speed is half a meter per second. Well done if you got that. You'll know if you've got the equation right in just a second. So there we are. We can calculate the wave speed, frequency or wavelength from the following equation. So I'll just say again, you need to know and recall that equation. So speed equals frequency times wavelength, and we use v for the speed because we also use it for velocity. So v equals f times lambda. That's the Greek letter lambda. It looks a bit like a Y that's fallen upside down. So the units then, the speed's in meters per second, the frequency's in hertz, capital H, HZ for hertz. It's a capital H because it's a surname, Heinrich Hertz, from a previous lesson, and the wavelength, like any other length, we have in meters. Remember, this equation comes up a lot and you may not be given it in the exam. Question 3 then. So from memory, I want you to write down the wave equation. That's the equation that links the frequency, f, wavelength, lambda, wave speed, v, for a wave. And then I want you to write down the units for me for each of the 3. Units of frequency, units of wavelength, and units of velocity. I'm just going to give you a minute. Let's self-mark then. So velocity equals frequency times wavelength. That'll just be 1 mark in the exam. And then the units, frequencies in hertz, HZ, lambda, that's the wavelength in meters, m, and v, velocity, meters per second, same speed. Now we're going to model the use of the wave equation. Mr. Marcy's done a video clip for us. He's the head of science at Outward Academy, Acklam, and he's using a whiteboard and he's doing some substituting in. So just follow what he does, and then after that I'm going to get you to do a couple of questions.
In this section of the video, we are going to practice using our formula. So whenever you have to solve an equation, the first thing you always do is you just read the equation straight through. So a sound wave has a wavelength of 17.15 meters and a frequency of 20 hertz. Calculate the speed of sound. So once you've read the equation, what we now do is we read it again, but we're looking to extract from it. So we want to extract any numbers, and we also want to figure out what the question is asking us to find. So the first thing you do is you look at what the question is asking you to find. So this says calculate the speed of sound. So it wants us to calculate the speed. So I'm going to put a box around that term. And the speed in the equation, remember, was the symbol v for velocity. So the sound wave has a wavelength of 17.15 meters. That's another number, so we're going to underline it. And we look at the unit. Which part of this equation is in meters? Well, meters is wavelength, but it also tells you there. And remember, we use this symbol, lambda, to represent wavelength. And a frequency of 20 hertz. Now, that's actually the lowest frequency of human hearing. Human hearing is 20 to 20,000 hertz, or 20 kilohertz. So this is the lowest, and hertz, that must be the frequency, and frequency we use an F. So once we've extracted our data, we're going to list them down the side here because we want to make it really, really clear when we're doing our calculations where these numbers are coming from. So we can just write them down. So we've got wavelength here. So the wavelength is 17.15, and we put the unit in meters because we need to check it's in the right unit. The frequency is 20 hertz, and the speed is unknown, so we'll put a question mark in there, but we should put the unit as well. So anything that's speed, remember our answer will be in meters per second, so we might as well put that in there so that we can check it when we get our answer. Okay, so now we've extracted the data. The next thing we need to do is we need to ask ourselves, are these units correct? So is wavelength in meters? Well, yes, it is, so that unit is correct. Frequency in hertz, yep, that's correct. And velocity in meters per second, yeah, that's correct. So we don't need to do any converting. These numbers are absolutely fine. So once we've got this, the thing we do now is we write the equation in symbols that links all of these values together. So we've got a wavelength, we've got a frequency and a velocity, and there's only one equation that links these things, and it's V, so velocity, and we're going to spread this out, so we might as well use all of the space, equals frequency times by wavelength. Now, once we've got our equation, what we're going to do is we're going to substitute. So we're going to substitute our values straight into there. So rather than having V, we go down to here and we see what V is. Well, V is currently question mark. So we could put a question mark, but it's easier to keep it as V. So we're going to keep that as V. Follow down, equal sign. Now, what does the F symbol? Now, F has been replaced by this 20 hertz. And we don't need to put the units in. The units, we just need to have checked that they are right. So we're just going to write 20. Follow down, multiplication. And rather than lambda, we are going to put in 17.15. Again, don't need the units. Okay. So what we need to do now is we need to check that the thing that we are trying to calculate is actually the subject. So we are trying to calculate the speed, V. Is that the subject? That means that it's on its own on one side of the equal sign. And yes, it is. So that means that we don't have to rearrange. We can just go and we can combine, we can just calculate these numbers. So that's what we're going to do now. So we're just going to do 20 times by 17.15, and that will give us V. So V will equal, now what I'd like you to do is I'd like you to pause the video now, and I'd like you to try this sum for yourself, and then come back to the video and I will carry on and I'll solve it for you. Okay, so you get your calculator. So we've got our sum, which is 20 times 17.15. Oh, better turn it on. 20 times 17.15. That's right, it's really important to check your calculation. 17.15 equals, and we get 343. Now we aren't finished yet, because what we have to do is we have to check that we've got the right number of significant figures. Now we aren't told anything here, so that's fine. We can just leave it as this. If we aren't told anything, what I would always suggest is you do 2 decimal places, but there are no decimal places here, so that's absolutely fine. And the last thing we need to do is you need to make sure that you've got some units on here, because otherwise it's 343, but you're not telling the examiner what. It could be 343 lollipops for all you know. So 343. Now, what are the units of velocity? Well, that would be meters per second. So 343 meters per second. Underline it for the examiner. Tell them this is my answer.
Thanks, Mr. Marcy. So some straightforward calculations then. Question 5 and question 6. You can have a minute. So question 5, I won't read it out. Not going to read it out. It's there on the screen. Just going to give you a minute. Just be a little bit careful with question 2. There's a slight trick in there. for you to work out what it is. Seconds. So, first question, pretty straightforward. We've got the frequency 100 Hertz and we've got the wavelength 3.3 meters. So we write the equation down, V equals F times lambda. So that's 100 times 3.3. Gives us 330 meters per second. Question 6. This time, a little bit of a catch. Be careful because we've been given the wavelength in centimeters, which we can't put straight into the equation. So we've got 120 centimeters, which is 1.2 meters. All right, back to Mr. Marcy. This time slightly more complicated in that we're going to need to move this equation around after we've substituted in.
In this part of the video, we are going to look again at using calculations, but in a slightly more complex way. So again, we'll use the same steps. So we'll read the question. A sound wave is oscillating at the highest frequency a human can detect. That's 20 kilohertz. That's 20,000 hertz. Calculate the wavelength of the sound. So again, let's underline any values, so any numbers that we see. Okay, so the first one we see is this, 20 kilohertz. Now, hertz is frequency, so this is going to be our frequency, but it's not just in hertz, it's in kilohertz. I'm going to put an apostrophe so that I know I need to rearrange. What am I trying to find? Well, it wants me to calculate the wavelength. So there we go. Okay, and wavelength is here. So that's all the information we can get. Let's write down what we've got. So we've got the frequency. And we know that that is 20 kilohertz. And we are trying to find wavelength. We don't know that at the moment, but we do know that wavelength should be in meters. And the other thing we'll need in this formula, frequency, wavelength, is we're going to need the speed. We're going to need the velocity. But the question doesn't tell us that. However, I've done this on purpose because in the previous part of the video, we calculated the speed of a sound wave. This is an example of a linked question. This might be the second part of a question. The first part of the question might get you to calculate the sound wave. And in this second part, you might be asked to then use that information to calculate a sound wave with a different frequency and what that wavelength must be. So we got 343 meters per second as the velocity. Okay, you wouldn't be expected to remember that. It's a good thing to know, but you wouldn't be expected to remember that. It's just I thought I'd put that in so that you can remember that these equations all link together. So we've got our data extracted. Next we need to do is we need to check if they're in the right units. So kilohertz for frequency. Nope, that is not in the right unit. So we are going to have to convert. And we're going to have to turn that into hertz. Now kilo means you've got 1,000, like kilometer is 1,000 meters, kilogram is 1,000 grams. So this is 1,000 hertz. So we've got 20,000 hertz. So all we do is we multiply our 20 by 1,000, okay, which will give us our conversion. So have a go at that now. Quite straightforward. We don't need a calculator for this one, but it's always good practice in science. You've got it available, so always use it just to check. So 20 times by 1,000 equals 20,000. So 20 hertz. Again, that's the one we want to use in our equations. So we're going to put a cross through that so that we don't accidentally use it. But we're not scribbling it out because we're showing the examiner what we've done. This one, we don't know, it is going to be in meters. And this one is in meters per second. So that is the correct unit for velocity. So all the conversions are right. So we've extracted, we have converted. The next thing we do is we write our formula. I'm going to write it here. So V equals frequency times wavelength. Now we're going to substitute in. So it's exactly the same steps as we were doing previously. So V, do we know what V is? Ah, yes, we do. It's 343. So 343 equals frequency, F. Yep, we know that is 20,000. And we're going to multiply that by the wavelength, which we currently don't know. So we're going to leave that as wavelength. Okay, so now we need to ask ourselves the question, is the thing that we want, is the subject on its own on one side of the equal sign? Now the subject, the thing that we want, the question mark, is the wavelength. Well, that isn't on its own because that is currently being multiplied by 20,000. Because remember, maths works forwards and backwards. It's not like in written language where we read in English from left to right. Maths can work both ways. It's orders of operations. So this is, so we are going to have to get this on its own. So we're going to have to rearrange. So let's do that. Now currently, what we want, the wavelength, is being multiplied by 20,000. So we do the opposite to get rid of 20,000 to leave it on its own. So the opposite of multiplication is to divide, and it's divide by 20,000 because 20,000 goes into 20,000 one time, which would cancel out to be 1 times by whatever the wavelength is, and 1 times anything is itself. So that will get rid of those. But if we do an operation to one side, we've got to do it to the other side too. So we're going to divide that side also by 20,000. So now we should combine. We should do, and so we should combine and see what we've got. So we've got 343. Now I'm going to write it as a fraction because it's, I prefer to put it in the calculator that way. Divided by 20,000. So 343 divided by 20,000 equals, and now we've got 20,000 divided by 20,000, so that cancels out. So it equals the wavelength. So now the subject is on its own on one side of the equal sign. So now all we need to do is do our calculation and we should get our answer. So pause the video here, have a go at that calculation, and when you're ready, unpause it and you can check the answer. Okay, so 343, as I was saying, we use the fraction function, which is this button here. So we'll press that over 20,000. Okay, just always check your nought. So thousands has 3 zeros, so 20 with 3 zeros equals, press the SD button, and it gives us 0.0715. So we're going to write that in, we can write it in here, equals, sorry, that would equal that. So it's this side, 0.01715.
Thanks, Mr. Marseille. So 2 slightly more complex calculations for you to do now. Again, I won't read them out. Just be a little bit careful with question 8. have a look how you got on then. First one, relatively straightforward. So if you write the formula down first, so velocity equals frequency times wavelength, so 340 equals the frequency times 0.2. So the frequency then is 340 divided by 0.2, which is 1700 hertz. If you've put 1.7 kilohertz there, that's absolutely fine. Second one, don't fall for using 3 as your frequency. 3 kilohertz is 3000 hertz. So 1000 meters per second equals 3000 hertz times lambda, that's the wavelength. So the wavelength is 1000 divided by 3000, which is 0.33 meters. 0.3 recurring is fine, but if there's significant figures marks in the question, you won't get them. So just be a little bit careful with that. So it's 0.33 meters to 2 significant figures. Plenary then. So just 4 conversions for you to do, and I want you to convert them to the standard units. So I'd want 2.5 kilohertz in hertz. 3 more for you to do, and about 2 minutes. It might be a bit long. Okay, I said I'd give you another minute, but I think most of you may well have done. Just be careful with centimetres. 100 centimetres in a metre, not 1000, 100. Okay, that should be enough. So 2.5 kilohertz is 2.5 thousand hertz, so 2500 hertz. 3 kilometres is 3000 metres. So 2 centimetres then, so 2 divided by 100, so 0.02 metres. And 250 centimetres per second is 2.5 metres per second. So well done if you've got those right. If you didn't, it's worth finding yourself some other conversions to do, and just keep doing them, you'll get better and better at them. So I'm just going to leave you then with a summary that you can pause the video if you want to make a note of these. There's a worked example at the bottom, one of the ones that we've done. Units and the wave equation, remember that was the most important thing, remember the wave equation, and then some unit conversion examples on the left hand side there. So thanks for watching, and I'll see you for waves next time.